In this video, we will discuss about what is computer, its components, types of softwares, operating system, and how the softwares run on our computer. And then finally, we will see how the code we write in C++ or C language is executed. So let's get started. What is a computer? It is an electronic device designed to process data based on instructions. It can store, retrieve, and process information. Now, computer works in the form of 0 or 1, which is also known as binary. But why? Computers are made of billions of transistors, and they are mostly found in CPU and GPU. Now, this transistor has only two states, on, which is represented as 1, or off, which is 0. Also, binary system is less complicated and more reliable. Now, a computer is composed of two things, hardware and software. Hardware are the physical components that can be seen and touched. These include CPU, RAM, monitor, or storage device, etc. Whereas software is composed of code and data. It consists of a set of instructions that utilize the hardware to perform various operations. By the way, in context of mobile devices, software is also referred as app or application, such as Facebook, PUBG, etc. Every app installed on your phone is a software. One thing to note is that hardware maintenance is costly as compared to softwares. But why? It is because when there is any problem in hardware, we have to physically repair it or replace it, which is costly. On the other hand, if we are having a problem with any software, we can simply reinstall it or wait for its new update and it will be fixed. Some major types of softwares include system software and application software. System softwares manage all the major functionality of your computer, whereas application softwares are made to fulfill the needs of users. You must be wondering why I am telling you all these terms. Well, I want to tell you about a major system software that is called operating system. Now, what is operating system? The operating system is like the boss of your computer. It tells the hardware what to do and manages all the softwares like apps and games etc. you use. Operating system makes your computer work and helps you interact with it. Examples are Windows, Mac, or Linux. When we use Windows or Mac, we find it so smooth and easy to use. All we need is a mouse and a keyboard. But behind this smooth display, there is a lot of coding and a lot going in the CPU while we are running any software. Now focus as this is important. What happens when we click to open any software? Now we know that software is stored in your hard drive or SSD, right? But for it to run, it cannot run there. Now listen carefully as you will need this knowledge for your entire life. What happens is that when we open any software, it is first loaded from the storage device into the RAM. Again, the question is why it is loaded in the RAM? Well, RAM is like the factory of your computer. It is much faster and closer to your CPU than normal storage. This allows your system to do processing faster. This is why having more RAM can often make your system feel smooth, especially when you are running multiple softwares on it. Finally, let's come to the main point, why I was telling you this all, so that you get an intuition about how this all works. Now we know that software loads to RAM and then from RAM, CPU executes it, right? Same way, the code we write in C++ or any other language, it also runs on our CPU. And just like every other thing in our computer, it is also converted in binary 0 and 1. But there is an entire process that goes on in the backend. So let's see it all, because these things are mostly ignored while teaching programming, and the students don't understand how this all is working at the backend. Here we wrote a hello world program on our IDE. Now we know that this is not in binary, right? When we save the program, a CPP file is generated. This is also known as source code, and it is in C++ language. Now, when we click on the build button on the top, it generates a binary executable file. But how? Let's see all the steps. Pre-processing. It checks for the hashtag include, and then it searches for what is written in angle brackets. And when it finds, it copy everything written on that file and paste it at the location of hashtag include directive. However, modern compilers are smart and they only copy the contents that are actually used in the code. This code is then compiled. The compiler takes the pre-processed code and then translates it in assembly code. Assembler then takes this assembly code and translates it in machine code. You can see the example of converting assembly into machine. Now, from this step, a file with .o or .obj extension is generated. Step 2 and 3 are often happen together, so at some places you might see written that compiler generates object file. In future, we will create programs with multiple source code files. So what linker does is it merges all the object files generated by assembler into a single file, and the result of it is a binary executable file with .exe extension on Windows and no extension on Linux or Mac. These four steps happen when we click on this build button on our IDE. Till here, we are having a code that is ready to run. So now, when we click on the run button, the operating system that we discussed earlier, that operating system loads the executable file into the RAM, which is main memory, and then the CPU starts executing machine code, also known as binary executable file. And finally, then the CPU starts executing the machine code. Let's summarize this all. When we click on execute button, our code from high level language is translated into computer understandable language, which is machine code. And when we click on run, our operating system, which is Windows, Linux, or Mac, it allocates space for the code on RAM, and then it is executed by the CPU. That's it. It must be seeming so complicated. I understand, but you just have to understand the logic of how the things work. No professor explained in this detail in our universities. You can watch it again. You should take notes of this lecture or save this video to watch in future. But surely remember this video.